again, Micromeasurements has different options for shear and torsion measurements. Here we've got a full bridge gauge for active grids. And over here we've got a half bridge gauge, actually another one on the other side as well. What are the pros and cons of these two different gauge types, and what's the advantage and disadvantages for shear or torsion measurement?
I'm glad you asked, Kevin. So this first gauge here is, like you said, a full bridge pattern. We have 4 active grids on one backing. It's a little bit more convenient. You've got all your wiring, all your application in one spot. This half bridge requires a little bit more alignment on each side because they need to be perfectly 180 degrees apart from each other, but they're the same gauge, just oriented perfectly on the opposite sides of the beam from each other. What this does is this cancels out bending, where this full bridge on one side does not cancel out the bending. So if you see, as I go through to apply a little bit of torque just with my hand here, the magnitude of these signals is almost the same. We've got about 130 up to 150 microstrain. I can even get it up to 200, but they're going to match each other pretty well. As I start to try and bend it side to side, you can see that that full bridge gauge here on channel 2 is a lot more signal where it really shouldn't be seeing any at all.
Okay. Yeah, this full bridge gauge is very sensitive to alignment, more sensitive than the two that are spread out. This gauge here, if we were to rotate that just 45 degrees, it would become insensitive to shear and completely sensitive to bending and axial. So there's only 45 degrees of rotation. You can imagine if you're off 1 degree, this is going to start to introduce an error in the measurement. It's only going to get larger because 45 is not a large number.
No, it's not.
Okay, thanks, Quinn.
Thanks, Kevin.